Hello to all you folks sitting in front of me and all the folks joining virtually. I am honored to be the first live presenter. I have an error message. We're having a little bit of technical issues, which all the remote presenters will not have. I'm sure you guys didn't miss the tornado siren last night at about 5 a.m., but you also are enjoying a more relaxed presentation mode. Let's see. Whenever I stand on the shore, can you guys hear me okay? Yeah, okay. Whenever I stand on the shore, I find I'm often trying to visualize what happens beneath the surface. What shape does that headland take below the waterline? And why are the waves breaking so far from shore? What creatures are under there? And in general, what does a benthic scape look like? But how do you describe it on a map? For me, that means identifying the depths and the different features, the headlands, the tidal flats, the sandbars, and the tombolos, and using color to express the natural environment. Let's see if this works. All right. When I first thought of making a surf map of Saco Bay several years ago, it was because I surfed there a lot and had started to unpack more information about the waves. I knew of Joseph Kelly's work, a marine geologist at the University of Maine, and had read about these offshore valleys that he described in his papers. I wanted to describe these on a map and connect what happened to wave energy as it traveled across over these valleys and then landed on shore. As I worked through that, the project also expanded into describing not just offshore characteristics, but inland wetlands as well. And when I started Fox Island's map, I used many of the same techniques that I learned from the Surfing Saco Bay map, but because of the nature of the data and the landforms, there are some unique challenges. And to note, the map on the right, the Fox Islands map, is an exploratory version of the original. The original map focused on the terrestrial environment, and I want to revise it to include much more bathymetric information, which is what you're seeing. I typically create all my final maps in Illustrator with Map Publisher and Photoshop. Pre-processing is done in QGIS and ArcGIS. Okay. Gathering data and choosing a zero. Higher resolution bathymetric data is far less common than high resolution terrestrial data. While there is good offshore bathymetry for this area and excellent terrestrial data, there was only one data set that competently covered the very near shore of Saco Bay. This 10-meter topobathy data set, shown here, clipped to the area. I also used a 2-meter DEM to detail coastal features. If you're thinking of including depth numbers, 100 feet deep, 200 feet deep, for example, it's important to consider what vertical datum is being used. The vertical datum establishes at what elevation zero is. For example, one data set may use mean high tide for zero, and another may use mean low tide. For this area in Maine, that's about a 9-foot difference in elevation and renders a very different coastline. For several reasons, I decided to show the ocean at low tide. Not only is this beach best surfed at low tide, so anyone looking at the map would have better reference points, but the lead surf forecasting group, Surfline, uses low tide as their baseline. Also, most nautical charts use one of the low tide means as their zero. So if one happened to be looking at a chart of this area, it would be great if the depths came close to matching. But with the 10-meter topobathy and both with the 10-meter topobathy and the 2-meter terrestrial data sets, they both use mean high water. So to adjust the elevation numbers to mean low water, I simply used a raster calculator to recalculate the Z values. That meant subtracting about 9 feet. Defining the coast and creating a base hydro layer, mostly because the vector hydrological data sets I considered just didn't do a great job of defining the shore. I created my own shoreline from the 2-meter data set. From that DEM, I generated several sets of contour lines like this set on the left. As you can see, the data is pretty messy as you move away from the shore. It's just globby. But the onshore contours, where the line becomes dense as they walk up the beachfront, are very good, and they agree with the low tide aerial imagery that I was also working with. Using Map Publisher to select the contour with an elevation of 0, then creating a larger polygon with Illustrator's pen tool, and finally subtracting the island polygons were fairly straightforward steps. And you can see the base layer that I drew on the right, that resulted on the right. I think there are distinct advantage to creating a vector versus raster-based hydro layer. With a vector layer, I get a crisp boundary that is easy to embellish with other information, other title marks, for example, or shading. I don't have to leave it at that color, but it becomes a continuum. It makes transitions between oceans and rivers smooth and continuous, and it's easy to layer over. If you want to add shading, it's easy. To layer the bathymetric tint over the base hydropolygon, I employed the ever-useful and magical multiply blend mode, and to reveal the clean edge of the base hydropolygon, I created a color ramp that went to white at the very shallowest edges. If you're not already familiar with it, the multiply blend mode ignores white, making it possible to view anything below something that's white. To ensure there was no color bleeding into the higher elevations, I used a double stop of white. I created multiple hill shades from different light sources to define undersea features that were otherwise lost. For the alternate hill shades, I modified Tom Patterson's technique in his online tutorial, See the Light, how to make illuminated shaded relief in Photoshop 6.0. But instead of masking a warm gold color to create an alpenglow effect, I inverted the hill shade to mask darker, low-saturated blues to create deep water shadows. Hopefully, this both enhanced the lost features and followed the notion that the further away, or deeper in this case, the subject is, the less bright it is. See his tutorial on his website, shadedrelief.com, to learn more. With the bathymetric layer in place and multiply blend mode set to 84%, I added depth contours. Here it's noticeable, at least when you're looking at the map in print, I'm not sure how clear it is on the screen, how effective this was for visually organizing the depth information. The detail on the left is sans contours, and the detail on the right includes them. It really helped to describe the continuum of blue as it walks up from deep to shallow. Okay, on to the problem child. Fox Island. When NOAA contracted with Fugro to survey parts of Penobscot Bay, a new undersea feature was revealed. The tight concentric ovals seen in the first detail on the left are thought to be volcanic in origin, or just southwest of Vinyl Haven. I was super excited to be able to include this in my revised map. The image in the middle shows the footprints of the different surveys. The footprint that is highlighted in the blueberryish color was collected in 1868, probably a Viledin line. The magenta beet colored data sets were from the 2016 survey and were collected using multi-beam sonar and LiDAR and have an overall 8-meter resolution. There are two other data sets that I was looking at, a 90-meter and a 3 arcsecond, but they are both very generalized. And then the problem. If I follow the recommended practice and downsample the data sets to agree with the lowest resolution, I lose this impressive undersea feature. If I mosaic the data sets at a resolution high enough to show the details of this new feature, then I'm committing a basic cartographic no-no, which in this case inspires false confidence in the details of the other areas. See the map on the right? I don't know if you can see it clearly enough in that northeast. Is that northeast corner really that smooth? I cannot publish this map because of that, or I won't agree to it. But I do have a plan. Reframe the map as a 3D image, viewing it from the south so that the north side basically disappears. I haven't had time to do that yet, but that is the next step. And then very briefly, common data sources. If you're working at a global scale, Natural Earth is wonderful. They offer prepared hillshades at various scales. NOAA, which is my go-to data source, also offers the eTopo 1, I believe. And then for the larger scales that I tend to work at, I always go to Bathymetry and Global Relief, the NOAA's website. And you can select by list, for example, the bathymetric data viewer or estuarine bathymetric digital elevation models, or by map, which is shown at right, which is what I always do. And that's a screenshot from the earlier image. ArcGIS also supplies data from the Living Atlas and has a bathymetry extension, which I've never used. So anyway, you can also find details for different bodies of water, Gulf of Maine, Gulf of Mexico, at either state agencies or research institutes. Okay. Okay, so maybe the best available bathymetric data is too coarse for the project scale, or there's not enough time available in the budget to take the time to deal with bathy data, or including bathymetric color ramps simply doesn't complement the map's aesthetics. Here are two vector alternatives that help define the edge. The first one can also give the illusion of depth. To achieve the look on the left in Illustrator, duplicate the base hydro polygon twice and apply a different inner glow effect to each, and of course, use the magical multiply blend mode to blend them. The uppermost layer uses a small increment of blurred color on the edge, with white in the center, and the second one uses a much larger blur of color in the center, white at the edge. Sarah Bell, hi Sarah, I hope you're watching, but if not, hello, has put together an excellent Illustrator tutorial for generating offset lines to create a classic look for shorelines. Please see her tutorial at petrichor.studio to learn the details. And thank you, Sarah, for putting that together and sharing it with here. Okay, bouncing to the next step. To close, I'd like to note how much I enjoy detailing the coastal environment. It's a passion of mine. From pushing dams to defining undersea features, delineating rocky headlands and other coastal elements, and working with low tide imagery to define tidal flats and pools and inland wetlands. And all through this process, I was creating new patterns in Illustrator. As a result, I've started an Illustrator-based wetland cartographic library, one that goes beyond using the ubiquitous emergent growth symbol to illustrate all wetlands. It's not ready for prime time, but I hope it will be next year. So instead of I spent a lot of time with wetland data, and the emergent growth symbol is certainly very handy, but maybe doesn't do the best of representing the kind of wetland that it is. But hopefully next year I will have more on that. Thank you very much.